All right, hi guys. Thanks for attending today, and hello to those online. I'm excited to speak about some updates from the ARC study that has happened in 2025. And I thought I'd start by, this is my title slide, warming you guys up a bit. But the agenda real quick is just going to be my annual review of what is the ARC study, for those who are unfamiliar or need a refresher. Go over some collaboration updates, and then discuss future plans. The text is smaller because it's one slide, so that's how my brain works, but it's not an error. Okay, so the warm-up, the graph warm-up. For those who don't know, I'm a new father this year. Yeah. All right, that's it. Okay, guys, see ya. So I often get asked, how is it being a dad? And give the very typical answers of, good, great, fun, awesome, rewarding, whatever. But like Fernando, my brain thinks in graphs, and so I needed to quantify this a bit. So here's one graph. Ages of people I've spoken to before birth, and ages are on the x-axis, number of people on the y-axis. Pretty normal distribution, I think, for my age. After birth, for some reason, there's just a lot of infants all of a sudden in my vicinity, and I'm definitely speaking less to people my age. So that's my social aspect. Percent comprehension of infant dialogue, time since birth on the x-axis in months, and percent comprehension on the y-axis. Really amazing how much I understand now. I didn't understand anything before, but I feel like I can just talk with them fluently now. And then percent chance I bring up my son in a setting where no one asked. Again, time since birth on the x-axis, and percent chance on the y-axis, and it very quickly went to almost 100%, and here we are. If you're wondering at the end of this, what the point of this was, don't worry about it. Just remember the science. Anyways, but there is a loose connection. Okay, anyways. So the ARC study is the ALS Research Collaborative. You've heard about it already a little bit. It consists of the ARC study, which is how we collect the data, and then the ARC Data Commons, which is how we share the data. And it's de-identified data with researchers pretty much around the world. As you know by now, probably, the ARC study is a natural history study, so it's a type of study that aims to learn more about a condition or disease through observing its natural progression. And at a high level, the ARC study launched in 2023 and is a continuation of a longitudinal data collection effort that started back in 2014. And to date, over 1,800 participants have consented to the study, and 1,200 participants have given at least 3 or more data points for any specific data type. And the study is fully remote, so everything can be done from home, and there are no costs involved. So the goals of the ARC study are to better inform our drug development efforts, as you heard from Fernando. Could be through finding new targets relevant to ALS subtypes, or developing new models to test potential therapeutics in. In addition, we're hoping to discover or validate biomarkers that can help us understand or monitor progression better, either through fluids, or specifically in our case, blood-based biomarkers, and then digital technologies. And today's presentation is going to focus on the digital technologies, but if you have any questions about any of the other aims and how the ARC study impacts those, feel free to come find me and talk to me during any of the breaks. So participation starts by going to arc.als.net and creating an account. We have pretty broad inclusion criteria. People just need to have an ALS diagnosis or be a known carrier of an ALS-associated mutation. We've recently also made a push to collect healthy volunteer data as well. And you have to be 18 years of older, of course, and communicate in written English. Once the account is created, people can complete the consent process at their own pace. They can save and exit, ask us any questions at any point, and decide, should they want to participate in the study. It usually takes about 30 minutes to do in one sitting. And after a participant consents, they get access to their own portal, which looks like this, where most of the study tasks are completed and where you can view your data. So there are 5 main tasks associated with the program. These are typically completed once, monthly, or quarterly, and everything's optional. So we know that there's a lot that can be going on at any given time, and so we appreciate whatever data people are willing to contribute at any point. So I'll go ahead and quickly run through the different data types. So the ALS functional rating scale, sure is nothing new to a lot of you. It is a 12-question assessment of various common functions and tasks that I've listed here. The ability to do these tasks are rated on a whole number scale of 0 to 4. It's a widely accepted measure of disease state and progression, and the FDA recognizes it as a main outcome measure, usually in detecting drug response during clinical trials. But it comes with some caveats. So discrepancy between administration at different clinical sites, its subjectivity, and its restriction to 0, 1, 2, 3, and 4 as answers limits its hampers its sensitivity. That being said, it has a very important place in clinical care and research as a standard measure of ALS, but I think it's fair to say at this point that the field is looking for ways to supplement the FRS with more information, and TDI is part of that effort. Next data type we collect is a multitude of surveys. We want to learn about various topics like family and medical history, medications, supplements, what industries people have worked in, and where they've lived, and so on. There's a gap in understanding of how one's environment may have played a role in triggering or augmenting one's disease, so it's important that we collect this information. You'll hear a little bit more about that from Danielle later. Next is speech tracking, which involves folks calling into our automated phone system once a month and recording a set of 5 phrases, which we then convert into audio files. And then in collaboration with researchers at Google, they developed a machine learning model that essentially takes the recording, turns it into an image, and gives it a score based on the quality of the participant's speech. Scores are visualized on a graph like the one you're seeing here, and are displayed in the portal looking like that as well. So this graph is an example of the ALS FRS overlaid with the voice recording scores. And you can see the model pretty impressively tracks with the FRS score. We see this a lot. But it offers a little more information on when the speech is between a 3 and a 2 on the FRS. So you might imagine in a clinical setting, in a clinical trial, in a response to a drug, you could see an improvement from maybe 2 to 2.8, but you wouldn't maybe capture that on the FRS. So that is important, sensitive information to have, and it's captured in an objective way with the model. Of course, it's still a very experimental method, and others have been taking this and trying to improve it, and others have used other methods as well. But it's one of the ways we're trying to address the limitations of the ALS FRS. So that was to capture sort of like a bulbar symptom aspect. And to capture the limbs, we do activity tracking through accelerometry. This involves sending a set of 4 of these accelerometer devices to people's homes 1 week out of each month to look like they're on house arrest. And then they wear them on their wrists and their ankles. So we ask them to wear them as much as they comfortably can during that week. And so that's passive wear time data. And then during 3 days of that week, we ask them to do a set of prescribed movements along to a guided video. So as you can see, there are seated arm lifts, leg lifts, and toe touches. So that's the active wear time data. The devices are measuring acceleration, so the more force you put into the movement, the higher the score will be. And like with the voice scores, you'll be able to see that data on a graph in the portal. And to make a similar point I did with the voice recordings, here's a figure from a publication by one of our longtime collaborators, Dr. Anupam Gupta. One of the main findings of the study, and what you're seeing here, is that the accelerometer data here on the top, and these lines are the different limbs, we're able to detect change in symptom progression earlier than the FRS could, and that's what this red line is denoting, is when the FRS started to detect change. So, and this is, on these graphs, almost a half a year ahead. So for clinical trials and care, like having this information is really important, especially when you're considering that you can detect symptom change up, that far ahead. Lastly, we have remote sample collections. We started this aspect of the study in 2019, and we partner with a variety of mobile phlebotomy I can't say that word. Phlebotomy groups. It's a concern because I do this for a living. So we cover a lot of the US now, which is really amazing, and also Ontario, Canada, and we're looking to expand further into Canada as well. But we collect samples from participants roughly every 3 months if we have coverage, and use them for various omics analysis. So you're seeing genomics, transcriptomics, and proteomics. Genomics, obviously, to look at genes. Transcriptomics, usually to look at RNA levels and changes between draws. And then proteomics is a similar thing, looking at different protein levels over time. I won't be covering much of the omics today, but you can check out some of our work we did with neurofilament light last year at Josh Berman's poster during the poster session. And of course, come find me if you're interested in any of the omics data. And then this is not a task, but I want to touch on this, is the option to import electronic health record data. Should a participant choose, they have the option in their portal to link their EHRs and share their clinical data. This effort was accomplished in collaboration with Unite. It was a really great team there. So they had this tool on their own platform, and they worked with us to embed it into the ARC portal. And since we implemented it over 2 years, just about 2 years ago, we've had over 100 people link their EHRs and share. It's an insane amount of data that comes with it. It's over like 2 million data points. But it's exciting because we can capture data that we don't have in ARC, like respiratory measures. We can compare like clinically administered FRS to our own FRS, or look at biomarkers data that may come in through the EHR and compare it to assays we run in-house or using vendors as well. So I won't say any more about that. Danielle's going to talk about it. And don't come ask me about it either. You should just go talk to Danielle, because she's been working a ton on this. So those are all the main points of the ARC study. And as I mentioned, the second part of the ARC platform is the ARC Data Commons. So it's a browser-based tool where researchers can jump in, access the de-identified data, and download basically almost everything I talked about today. And so all the projects that I'm about to update you on have come through researchers requesting access and gaining access to the data commons. All right, so I broke it out by data type here, so you can see what groups are using sort of what data type primarily. And I won't cover everything today because of time, but I'll use this slide to shout out LifeArc, who we've been working with over the past year to analyze our proteomics data. Paula Sebastiani and Zaewon Song at Tufts, who have been helping us analyze our genomic data. At the top, researchers, it's a preprint, researchers at Regeneron and Connexa have been evaluating models that can improve our interpretation and sort of analysis and understanding of the ALS-FRS. And so they used our data along with the PROACT database for their work. And I just put Danielle's face there. As I said, she's going to go talk about that, the surveys and the HR data. But I will mention that we're continuing to work with Pat Dolan on the CDC-funded grant that we got that is assessing risk factors. And then I'll touch on the sort of the bottom left in the next few slides, and answer ALS at the top. So last year, when I was up here, we announced that we were partnering with Answer ALS to combine our two data sets together. For those who don't know, Answer ALS collected data from 1,000 participants using different methods, different data collection methods, sort of like we do, but they were doing it through clinics. And so we embarked to join the two data sets so that we can have one huge data set, but also so that researchers can access both data sets in a sort of a convenient platform. So in particular, Answer ALS had this robust platform for analyzing omics data, and we didn't really have something like that. So this is a huge benefit, especially for researchers who want to access omics data. There's pipelines that you can use up there and put in the omics data and work through it. This was our first large-scale data harmonization effort. We learned a lot from it. It's a lot of work. And we're definitely going to learn what we use to continue to harmonize our data with other groups. The one that comes to mind is the ALS Knowledge Portal that was recently launched. So we're looking forward to that. And then I'm going to shout out Danielle, who's here, Gwen and Hannah from our team, Terry, Brandon, Dylan, and Kelsey from the Answer ALS team for pulling this together. It was just such a huge effort, and it took pretty much the whole year to do, but it's available now, so it's really exciting. So I lied. This is not our data, but this is some data from collaborators, but working with data from everything ALS and modality AI. It was part of a poster that Trace presented at Neil's last week, but I thought it was a succinct display of a point I'm trying to make today. So what you're seeing here, let me get the laser pointer. So this graph is 21 people and their ALS-FRS slopes over a 6-month period, which is a common clinical trial length. And each bar is a person. And as you can see in the red circles, there are a lot of zeros for slope. So if these people were in a trial, they would not report any detected change as measured by the FRS speech subscore. And then when you go ahead and look at the various assessments of speech that modality AI uses, there's a very clear change in performance that's happening using all of these other methods that's not captured by the FRS. And so we went ahead and did something similar. I guess if you look with your binoculars, you can see in the 6-month period that we simulated as well, we found similar results. So the red circles are containing all the zeros on the FRS speech subscore. And then when we use our own voice recording analysis method, you can see all of these people have changes. Some have positive changes. So it's really important information that we're missing here, and especially in a smaller, when you think about a smaller length or a shorter length of a clinical trial, this is important. And I also think this is a good sort of display of two studies who are using, they're collecting data from people with ALS in different ways. So that's similar, but we're doing it in different ways. But we come sort of to the same, we're proving the same concept here, using different sample sizes and different participants. Thank you to my team member, Joe Gill, for helping me pull this graph together. From the same poster, Trace, along with Dr. Gupta, who I mentioned earlier, evaluated the utility of our accelerometer data in a similar simulated clinical trial setting. So these graphs are showing progression slope captured by either the FRS or by the accelerometers over a period of 1 to 3 years here on the top, and a period of 6 months on the bottom. It's small, so I'm just going to summarize in the table that sort of went along with this. If you look at the change in slopes by the two methods over more than a year, you'll find that there's not much of a difference. They both track progression somewhat similarly. At just 1 year of measurement, there starts to be a difference. You'll notice the sensors are a little bit faster than the FRS, but it's not a huge difference. And then when you go to 6 months of measurement, it becomes a pretty stark difference. The point being is that the devices are detecting the change faster than the FRSs, and that is sort of the major concept. And in an environment where clinical trials can't always be longer than 6 months, and they often have 6 months, even if they go on, they have a 6-month sort of intervention period. We should try to make sure our outcome measures are the best for what they are for those time periods. The FRS is there because it does track progression well over a very long period of time. But when we're looking at drugs, we don't always get years to use the FRS. So, I thought this was a really neat idea that they presented. Oh, that's the thing I said. Yeah. So the last study I'll touch on is using our accelerometers. Again, longtime collaborators, Marcin Strykevich and Katie Burke at MGH have been doing a lot with our data the past few years. This work is in peer review, and it's visualizing when participants do the arm swing motions. So that's what these up and down graphs are, over a period of 3 years, so December 2015 to 2018. And you can immediately see the decreases in amplitude and frequency in this one participant over time. And these metrics were quantified on the graphs below. You're seeing the number of repetitions they do, how long it took them to do it, the magnitude of the acceleration. And to the right is the graph of the ALS FRS for that same person over the same time, which, if I've made my point clear by now, there's times when you're seeing more sensitivity in the graphs, right? So this flat-ish section of the FRS, the motor subscore specifically, is not present when you look at any of these other metrics using the accelerometers. So again, the point is detecting or having more sensitivity in your measures, capturing more information. And this is a year period too. It's considerably long. So I'm not just here to rag on the FRS, I promise. But if I've made my point clear, we need to do more, especially with the somewhat rigid clinical trial landscape, to make the most of each participant's time and effort And improving outcome measures is one of those things, and it means a lot to what we're doing. So it does beg the question, why don't we just use any of these? There's so many good ones, right? Well, we have to get the FDA to recognize these measures as meaningful, so it has to go through rigorous review if we want them to eventually become biomarkers or primary outcome measures or even surrogate outcome measures. So we have to, continuously test and retest and make sure that we can really pull out these measures time and time again. And then we have to assess their meaningfulness, of course, to the person living with ALS. And that's probably one of our biggest efforts right now, is understanding if these metrics actually capture something meaningful to daily function. And to that extent, we've been working all year with the Critical Path Institute and other academic and industry partners to evaluate all of these metrics, many more too, that we can extract from the digital data types and create a way forward to evaluate meaningfulness. And it's a collective effort. It's not just us. Many groups are working on this, but people with ALS are going to be a part of this too, because it's what is going to get us forward and get it in front of the FDA. Eventually, hopefully, for sponsors and clinical trials to use in the future. So that leads me to my future directions. As I mentioned, we're planning to create new surveys coming out of that collaboration to capture aspects of ALS progression that are meaningful. We're going to continue to collaborate with other organizations, as we have been all year, and further our data harmonization capabilities. And we still are looking to make the ARC experience itself better. There are some out-of-date aspects to it that we can update, new surveys, new ways to ask things as we've learned more with how the field has progressed. So that is where we're sort of directing our focus in 2026. Fernando mentioned it, and I didn't talk about it at all, but Champion Insights is our a study we're launching soon that is sort of like a sub-study or a complementary study to ARC, looking at high-performance athletes and former military members. There is a website if anybody's interested in learning more. Of course, acknowledge my team members who handle, the people you're seeing here are the people who handle the day-to-day stuff. And, we wouldn't be here. We get to work on so many cool things and help push the field forward. And literally, it wouldn't be possible without all the people who selflessly, not selfishly, maybe selfishly, I don't know, selflessly, give their time and effort, work with us with FedEx sometimes, and just donate as much as they can. It's really helping push us forward. It's pushing the field forward too. So thank you if you're contributing data to the ARC study. How's time?
Thank you, Alan. We have time for one question for Alan, so if anyone has a pressing
Left so much time.
question. All right, Carmen.
I hope it's important enough, the question. So are you seeing this ARC study and collection of data as a way that you could then in future measure the efficacy of the treatments or drugs in terms of seeing improvement? Is that a major reason for doing this?
So it's something we can do, and it's an important thing to do. I don't know if I would say it's one of our reasons why we started it, but we do capture people who are on certain medications. I'm going to separate being on a medication and being in a clinical trial, because we do capture when people are in clinical trial, but we don't know if they're getting the drug. If people are receiving medication some other way, or it's not necessarily for ALS or something, yes, that data we look at. It's super important. We want to be able to see, they'll fill out their medication surveys every 3 months, and we'll want to see if they've been on it, how long they've been on it, if they've stopped, and then go back and check their accelerometer data and their FRS and their speech data and see if there's been any changes. So that is an important part of what we do. It wouldn't necessarily be for any new drugs, I guess, is the point. But maybe looking for things that people, maybe their doctor recommended it, they don't know anybody else that's taking that specific medication. But in our database, maybe we find 15 people that are, and then we can, we can't do anything with that amount, but we can start generating hypotheses or look further, when we look at the collective data. Does that answer your question? You think so? Okay, I hope so. Cool.